Okay, so here is the answer, or an answer for quiz number 17. So this is a switch circuit at time t equals 0. So the switch is closed for a long period of time. And then as time goes, or at t equals 0, this switch opens. Okay, so what we have to do, remember that the current through an inductor is going to be, it's kind of this guy. So I of t is going to be, I at the final, basically as time goes to infinity, plus the initial current minus the final current, e to the minus t over tau, and tau in this case is our time constant, L over R. Okay, so we need to find, we need to find these guys, and then of course compute L over R. So how do we find let's look at the initial current. Okay, so this, what we're going to do is we're going to assume that this guy has been closed for a long period of time. So if it's been closed for a long period of time, everything's settled out, and this guy looks like a wire, okay? So the current is just going to be what runs through here if it's just the 2 ohm resistor. So my current, I'm going to basically have, I could look at, I don't know, I guess there's lots of ways in which we could solve this. Maybe let's do it using node voltage. So let's let V0 be here, and now I've got this current plus that current all equal to 0, and so we'll have V0 minus 18 divided by 3 plus V0 over 6 plus V0 over 2 has to equal to 0, and that means what if I were to multiply through by 6, I would have 2V0 minus 36 plus V0 plus 3V0 equals 0. And that implies, let's see, 2, 3, 6. V0 has to equal 36. So V0 is equal to 6 volts. And so my I initial, I0, is going to be V0 divided by 2, so 3 volts. Okay, so there is my I initial. Again, I solved it by assuming that this guy had been closed for a long period of time, meaning all the current, this guy basically looks like just a wire. And then I found what current flowed, okay? I'm sorry, not 3 volts. This is 3. Yeah, yikes. This is 3 amps. 3 amps. Okay, so now I need to find the final current. So to find the final current, final current, I assume that this guy has been open for a long period of time. Okay, so whatever, in this particular case, there's basically no voltage being applied to the circuit. And so the current, after a while, the current will die out, and it'll basically, it'll go to, there's nothing that's going to drive this current. So after a while, the current goes to 0. So I final is equal to 0 amps. And now I need my time constant. Time constant is going to be 2.0 microhenry divided by, okay, and then for my resistance, remember this is the Thevenin resistance. So I need to look at the resistance looking, thinking of this as a black box, or thinking of this guy as a black box and looking in. So what is the resistance that happens there? So I can find that by Yeah, I don't have any room here. Okay, so I can find that by doing some source transformations. So this guy, let's see, let's just redraw this circuit on another page. So I've got 18 volts, 3. Oh, and I guess it's R when this guy is open. Oh, so it makes it easy. So we're going to find the Thevenin equivalent when this guy is open. So basically, this guy is open means no current flows here. So when I look back in, it's just these two resistances. So it's just going to be 8 ohms. So my Thevenin equivalent here after time t equals 0, so R Thevenin, is just going to be 2 plus 6 equals 8 ohms. So here I would do 2 divided by 8, and so this is going to be for 0.25 micro. Is that right? So tau is going to be 0.25 microseconds. So now I can write I of t, and it's going to be my final, which is, my final, these are the things I need, 0 plus the initial minus the final, so it's going to be the 3 e to the minus t divided by 0.25 microseconds. And that is going to be my answer for the current.